Welcome to lesson 5, word problems, everybody's favorite. But truthfully, they're not bad. You just have to take your time to read the information and just pull out the necessary material to make your own equations. That's really the only difference. But something important that I want to point out that will help you a lot throughout this book is to keep in mind the number of equations must be equal to the number of variables or the number of unknowns. And yes, this means number, not hashtag, okay? It means number of. And so we're going to keep that in mind. In this lesson, they're not going to start introducing multiple unknowns just yet. That's going to come a little bit later in the book, but I did want to go ahead and say that so we can start taking that in and remembering that as we look at word problems. In our first example, we have the following statement. Twice the number is decreased by 7 and this quantity is multiplied by 3. The result is 9 less than 10 times the number. What is the number? So first thing we're going to do is we're just going to take all this information and we're going to turn it into actual math. This is an English class. This is math class. So twice a number. Twice means times 2, so twice a number, or you could put x. It doesn't really matter what the variable is as long as you're consistent throughout the problem. But we're going to go ahead and go with n. So twice the number is decreased by 7, minus 7. This quantity is multiplied by 3. This whole thing is multiplied by 3. And I will say this part right here is what gets a lot of people is knowing where to put your parentheses and things like that. So it's multiplied by 3, the whole thing. The result, that means equal, is 9 less than 10 times the number. Okay, so I'm going to write 10 times the number, but it's 9 less than. So that means we're going to subtract. What is the number? Okay, so from this point, I'm just going to solve. I'm going to distribute first. This 3 is going to go to both parts, so that's going to be 6n minus 21 equals 10n minus 9. And we know about change sign, change signs. So this is going to become plus 21, and this is going to become minus 10n. And those are gone because I switched their sides, so I changed their signs. 21. So this is now 4n, negative 4n, equals positive 12. And then we're going to divide by negative 4. And n equals negative 3. And we're done. We did it. Okay, so our next example is the number of ducks on the pond was doubled when a new flock came. Then 7 more came. The resulting number of ducks was 13 less than 3 times the original number. How many ducks were there to begin with? So the number of ducks on the pond was doubled. So that's, I'm going to use D since we're talking about ducks, and it was doubled. So that's times 2. So 2D. Then 7 more came. So plus 7. The resulting number, okay, so now we're talking about equals, and I don't know why I have 2 C's here. There we go. The resulting number of ducks was 13 less than 3 times the original. So 3 times the original is 3D, and it was 13 less than, so minus 13. And then after that, I've gotten all the information out of there, so now we just need to solve for D. Change side, change sign, so this is going to be minus 2D, and that's gone, and we're going to say plus 13. Now that's gone, and so 3 minus 2, that's just going to be D, and the original is 20 ducks. And we're done. Our last example for this concept is the sum of negative 7 and 6 times the number is multiplied by 5. The result is 332 less than 3 times the number. What is the number? So the sum of negative 7 and 6 times the number. So 6 times the number and negative 7. That's sum. Okay, so even though it says minus 7, it's still the sum. And then it says it's multiplied by 5. The result is 332 less than 3 times the number. Okay, so we have our setup, and now we just need to multiply it out and distribute and solve. So we're going to have 30n minus 35 equals 3n minus 332. We're going to move this over here, so minus 3n, and move this over here, so plus 35. and we're gonna get 27n equals negative, and I'm gonna get my calculator out because I don't feel like doing this stuff mentally today, and that's okay. That's why we have calculators. So we have negative 332 plus 35, and it's negative 297. Okay, and now we still gotta get n by itself, so we're gonna divide by 27. Divided by 27, looks like 11. Yep, it's negative 11. So our number is negative 11. And yes, you can get a negative for your answer on this. The second concept in this lesson is dealing with fractional parts of a problem when in a word problem. And I'm just gonna do a quick recap of this. If we had 3/8 of 40 is 15, we can convert this into a math equation by remembering that of means multiply and is means equals. So we can say 3/8 times 40 equals 15. And we know that this is a true statement. That reduces to 5, that's a 1, and 3 times 5 is 15. And so that's what we're going to encounter when we get to word problems like the next two that we do. Okay, so our first example is 1/5 of the clowns had red noses. If 30 clowns had red noses, how many clowns were there in all? And I actually would venture to say, I'm sorry, but if you don't have a red nose, are you a real clown? So that's just me personally. That's not what Saxon's getting at. So we'll still go ahead and play their game and solve their problem. But I do have big time questions for those who don't have a red nose. And only 1/5 had the red nose? Like, what other nose would you do? So that's not on topic, but I still wonder. Okay, so 1/5 of the clowns had red noses. So we know 1/5 had the red noses, and we know that we're gonna have a multiply and an equals, and we know that 30 of the clowns had the red noses. So that's gonna go in this part, because we need to know what is the grand total. We need to know how many clowns were there in all, and so this is how we set that up. And then we're just going to get rid of 1/5 by multiplying by the reciprocal, so 5/1. And this is super crooked. I'm very sorry for that, but it still works. So x equals 150. And so what I like to do is stop at this point and think, does that make sense? 1/5 of the clowns had red noses. That was 30. So if 1/5 had red noses, then there should be a whole lot more that don't. And we end up with 150. So yeah, that makes sense. So if 150 were in all, and 30 had red noses, that would mean 120 didn't. And 120 would be 4/5 of this. So we did good. It does make sense. It pieces together. Another way that we could solve this problem is going back a little bit. It's a little bit more elementary, but it still gets the job done. So, I mean, if it works, it works. Is we can also use a ratio box to solve this problem. And so it said 1/5 of the clowns had red noses. So I would write my fraction 1 and 5, because 5 would be our total and 1 would be the part that had a red nose. We also know that 30 had red noses. They want to know how many clowns were there in all. So I actually don't need this middle bar, and then we would set this up as a ratio problem. So it'd be 1/5 equals 30 over x, and I would solve by cross multiplying, and we would get 150 equals 1x, also known as x. But again, it works. It got us the answer, so I'm not gonna tell you that you can't do that. Our second practice problem is 7/8 of the Tartar horde rode horses. If 140,000 were in the horde, how many did not ride horses? So we're going to solve this two different ways. We're going to do our multiplication statement, and then we're also going to do a ratio box later just to show you that they both work. So the first one, we got our fraction of and is, and we know that 140 were in the horde. That's our total number. So it's going to go right here, 140,000. We don't know how many don't ride horses, and that's what we have to pay attention to. They want us to find how many do not ride horses. It's our unknown, so it's going to be x. But notice our fraction does not line up with this. Our fraction is for how many did ride horses. So if 7/8 rode a horse, 1/8 did not, and that's the fraction that we have to work with. And you can plug this into your calculator. Okay, and we have 1/8 times 140,000. Make sure you get the right number of zeros in there. And our answer is 17,500 did not ride a horse. Now let's try it another way just to prove that it works. Okay, so here we have our ratio box. We have the fraction and the actual horse, no horse, total. And we know that the fraction that did ride a horse was 7/8. So we know this part is 1. We know the total was 140,000. And they want us to find how many did not ride a horse. So we no longer need that top bar. We're gonna set this up as a ratio problem. So 1/8 equals x over 140,000. And then we have 140,000 times 1, so 140,000 divided by 8. And you can put that in your calculator and you will get, again, 17,500. So again, both ways work. I do not care which one you do as long as you get the right answer and you understand the concept of the problem. Doesn't matter to me. And that is it. We have completed lesson 5 word problems and we're just fine. Nobody passed out. We're good. We can do this. So I'll see you guys in class.